This tutorial will cover solving the traveling salesman problem with Java 8 and hill climbing. I will start with a demo of a pre-built application, and second, I will step by step write, explain, and run this application. And the application will find and display the shortest route, and it will use the Haversine formula to calculate distances between cities, and each city will be identified by its latitude and longitude coordinates. This is a pre-built version of the application. So if I go ahead and run it, so we start from this route, and it has this distance in miles, and we take a look at this adjacent route, and it has Seattle and Denver flipped, and it has a shorter distance, so we proceed from here, and now we are here, and we take a look at the adjacent route, and we find it has a larger distance, so we stay. So here we have the same route, but again here we take a look at this adjacent route that has Houston and Denver flipped, and we find that it has a shorter distance, so we proceed from here, and now we are here, and we keep doing this until here we start from this route with this distance, and we do 100 iterations, and we consider, for the purpose of this tutorial, that if 100 iterations are done, then we have reached a potential maxima, and that means this is the shortest route that we found. Next, I will step by step write the application. So I will start by creating a new project which will be running on Java 8, and here I will have a city class which will be in this package, and a route class, and a hill climbing class where the hill climbing algorithm logic will be, and a driver class with a main method. Now the city class will have a longitude, a latitude, and a name, and get methods for each one, and a toString method that would return the name of this city, and I will define those three constants: the Earth's equatorial radius, and converting degrees to radians, and converting kilometers to miles, and we will initialize the name the latitude and the longitude in the constructor, and we will have a measure distance method that measures the distance in miles between this city and the passed-in city. So here I will start by calculating the delta longitude and the delta latitude. So city dot get longitude minus this city dot get longitude. Same for the latitude. And we will use the Haversine formula to calculate and return the distance. So here we are using the delta latitude and the delta longitude, and here we are using this the result of this. Now going to the route class, it will have an array list of cities in this route and a toString method that prints out those cities, and two constructors. The first one have an initial array list of cities passed in that is used to initialize this array list of cities, and then shuffle them. And the second one initialize those cities using a pre-existing route instance. And I will have a get method for returning this array list of cities, and a get total distance method that calculates the distance between city 1 and city 2 and city 2 and city 3, etc., and then sums them up and adds the distance between the last city and the originating city. And I will have this convenience method, get total string distance, that uses the get total distance method and formats the double value that is returned, and aligns the rows in the total distance column correctly. And next, let's go to the hill climbing class, and we will need two methods here. So find the shortest route, and we pass it the current route, and it will make use of the obtain adjacent route method, where we randomly obtain two distinct indexes of two cities in the route, and obtain the cities associated with those indexes, and flip them and return this route as the adjacent route. And I will define this iterations before maxima. So it is the number of iterations. We check the adjacent route if they have larger distance than the current route, before considering the current route as a potential maximum. So let me define here iteration to maxima counter, and I will be using it in this while loop. So while it is smaller than this iterations before maximum. So let me define this adjacent route, and it will contain what is returned by calling this obtain adjacent route method with the current route. And let me define this compare routes string, and we will have two cases. If the adjacent route total distance is smaller or equal to the current route total distance, then we move to the adjacent route and we set the counter to 0. Otherwise we stay in the current route and we increase the counter, and we print out the route, the distance in miles, and comparing adjacent to current route. And if the iteration to maxima counter is equal to 100, then we are on a potential maxima. Otherwise we print out what is returned by comparing adjacent to current route, and let's return current route. So this does it for this class. And next let's go to the driver class. Now here let me define this array list of initial cities. So in main I will instantiate a driver and a route given the initial cities, and given that the number of cities here can vary, so the size of this column can vary. So I'll have this print heading method that is able to handle the changing size, and I will call it from here. And then I will print out the route and the total distance of this route, and I will call the find shortest route method on a new instance of hill climbing, passing in this route. So this should do it. Next, let me go ahead and test run this application. So we started from this route with this distance in miles, and we find that the adjacent route has a distance that is larger than this distance, so we stay. So we have the same route here, and we take a look at the adjacent route, which is this one, which has New York and Seattle flipped. And it has a shorter distance. So here we proceed, and now we are at this route, and we do the same thing. We compare against the adjacent route, and we stay, since we found that the adjacent route is larger than this route. and here we look at the adjacent route, and here we have Chicago and Dallas are flipped. So we proceed, and now we are here, and we stay for 10 iterations. So we did not reach 100 iterations. So when we find a shorter route, actually this one, we proceed. So now we are here, and we stay for 3 iterations, and then we proceed. Here we do 29 iterations until we start from here, and we do 100 iteration. So we consider this to be a potential maximum. So this is the shortest distance that we found this route.